on the entry, but our big task today, we got two goals: multiplying two fractions using the standard algorithm. So we just gave you that definition on our opening minute, and calculate the products of two fractions in real world and mathematical problems. Remember, so we're on page 33. If anybody comes in and asks what we're doing today, that's where you should turn to show them. Our first thing we're going to do, we're going to plot each value on the number line shown. So we're going to plot the values. Just to make sure everybody is on the same page, here is how we plot numbers in math. If I'm given a number line, I'm told to plot the number. I'm going to locate where that number is on the number line. So I'll do number 1 for you. So the first one is the number 2. So I go on my number line till I find the number 2. At the number 2, directly on the number line, I put a solid dot. All of those steps are important. Find the number, a solid dot on the number line. Is my dot above the line? Is my dot below the line? No, it is directly on the line where that number occurs. Another key note, if I'm given a number, if I'm numbering it, it goes below the number line. If I am labeling it, in other words, this is number 1. If I wanted to label number 1, labels go above the number line. The numbers themselves go below the number line. Yes? Do you have legs? Sign out, hurry up. You should be doing that at lunch. Okay, so you guys have 3 more to do. You can do numbers 2, 3, and 4, put them at the appropriate place. Any questions on how to plot a number? Okay, I'll give you 1 minute, go. Okay, these ones should have been really simple. Number 2 is 1/4. What 2 numbers is 1/4 going to be between? 0 and 1. So my bottom number tells me how many intervals I'm breaking it into. Top one tells me how many of those intervals I'm going to find it. So it says I'm breaking this into 4, so there's 4 intervals, and this one's at the first one. So that would be 1/4. Again, the number goes below. If I'm labeling it, it goes above. 4 and 1/3, what 2 numbers is that going to be between? I think, Nash. 4 and 5. Again, the bottom one says I'm breaking it into 3 parts. I'm going one of those 3. So 4 and 1/3 should be somewhere in that area, number 3. 4th, where is number 4, Ben?
4 is because if you divide 7 by 2, you get 3 and half. So you put 3 and half.
Good job. And so which numbers is it between? 3 and 4. And with 1/2, it's directly in between those. 3 and 1/2. Any questions on the plotting? Everybody understands what it should look like, right? Okay. Numbers under, labels above. All my dots are directly on the line. Okay? Sweet. Let's go ahead and go to page 34 then. Here's where you need the 2 colors. So if you don't have them yet, you can grab off the student desk. It could be anything. It could be pens, highlighters, colored pencils. Don't make one of them black, because if you're using black, you won't be able to see what's happening. So if you guys think back, one of our very first lessons we did together, we did the area models, right? To show how we were multiplying numbers. We use that for distributed property. So we use the area model to represent products, to determine factors, and list the multiples of given numbers. In the same way area models represent whole number multiplication, area models can represent fraction multiplication. So we're going to go through this process to help everybody understand the why of the answers that we get. So if we're going to look at the expression 1/2 times 1/4 in the area model shown, how are the factors 1/4 and 1/2 represented in the model? So how do I see the 1/2 and the 1/4 in the model? Don't everybody jump in at once here. Ben? So you're saying the blue is 1/2 or the red is 1/2? The blue is what? Really? Because it looks like half of it's red to me. Am I wrong? So the red's the 1/2? Does everybody see that? Kleinhorn, you don't see that? After 3 classes, you still don't? Who said no? Sanila, you don't see that half of it's colored red?
I see 3 of it's colored red. I see 3 of it's colored red, and on one like pink.
Well, that's red. You can see the crosshatches. Half of it is red.
That's only 3.
No, it's 4. That's also red. So if the red's 1/2, blue is 1/4, right?
Yes.
Is everybody okay with that?
That's 3 red and 2 blue.
No, this is also red.
That's 3. That is not orange. That's red and.
It's red and blue together, which technically would be purple if we were using highlighters. Okay. So how are they? So remember though, we're talking about area, right? What's our area formula? Area equals what? Length times width. So which is my length? What is my width? Alina?
Your length, I think, is 1/2.
Length is 1/2, so you're saying the length is red? So that means the width is 1/4. Is everybody okay with that? Is she right? Guys, honestly, it doesn't matter as long as you label the two. I could have said this is L and this is W and I'd still be okay. It doesn't really matter because I can turn this on its side, right? Does that mean the length and width changed? No, they're still the same. So it doesn't matter as long as we label them, right? Okay, now, what is the product of 1/2 by 1/8? So there's our question. Describe how the product is represented. So we have a task as well as a question. So first off, mathematically, what is 1/2 times 1/8? Does anybody know what that answer is? Zanila?
It is 2 8.
No, not 2/8. 1/8. Okay? So 1/2 times 1/4, actually let me write it the way they did it. 1/4 times 1/2 equals 1/8. How is that represented in our model? Isabella? Okay, there are 8 blocks in the rectangle. And that is our what? No. Isabella, what is that? What did I just circle? What do we call that number? The denominator. So that is our denominator. It's how many we divided our area into, correct? So where's the 1? Yes. Good. So we have 1 that is double colored. So that's the intersection of the 1/2 and the 1/4. It's where they both are, right? So that one is our numerator. So we get the answer is 1/8. So when we multiply 1/2 by 1/4, the answer is 1/8. Why? Because there's 1 block where 2 of them join over out of, now our area model is blocked into 8. Does that make more sense? Can you understand why 1/2 times 1/4 equals 1/8? How many give me a thumbs up? How many now understand it? How many are still kind of confused? How many are like, this doesn't make any sense to me. I don't get what you're doing, Mr. Moore. Okay, mostly thumbs ups. Good. So, hope everybody has these answers because we're going to now give you a chance to do it. So you have something to look back at. Let's go ahead and go to the next page. So we are now on page 35. We have a side note here, so everybody should already have your highlighters. Let's take note of our term. This was the one we gave you on your opening exercise. Or let me be fully honest, Miss Einhorn gave you on the opening exercise because she's one that's willing to do the work to put that together. The algorithm is a process or description of steps you can follow to complete a mathematical calculation. Hopefully you guys have all noticed. We have tried very hard to make this math easy for you by developing algorithms. Almost every lesson you guys are given like a step-by-step of how to do it. This is something Ms. McShannon, myself, and Ms. Einhorn all feel very strongly about. If you can understand the process, you can get the correct answers. Well, that process, the technical term for it is called an algorithm. So those steps help you to do this. So let's look at the expression 2/3 by 3/5. We need to model the expression and determine the product. So there's two parts to this. And show how the algorithm for multiplying two fractions less than 1 gives the same. Uh-oh. Have we given you an algorithm for this yet? No? Would you guys like an algorithm for this? Okay, so Keegan, don't write it down. The rest of you, please write this down. We're going to let Keegan just struggle because he doesn't want to follow along. We're going to write this. Normally, we label our algorithms is what we're doing. In this case, multiplying fractions. Guys, this is the easiest thing we can do with fractions. 3 easy steps. Step 1. Look for reductions. And this is where your 4 key numbers come in again. We're looking for a common factor on top and bottom. And this is actually really key. For reductions, I have to have one in the numerator, one in the denominator. I can't do it if both are numerator or both are denominator. That won't work. Okay? Step 2, and here's what makes multiplying fractions so easy. Multiply. Top times top. Bottom times bottom. Or, if you want to be mathematically correct, numerator times numerator, denominator times denominator. I just don't want to write all those that many times. Okay? So you're just going straight across. The tops, then the bottoms. Step 3 makes it really good because this is where we get our final answer. We simplify. As a side note, if I've done all my reductions in step 1, my answer is going to come out in simplest form. Makes it really easy. Questions on the algorithm? Okay, so you now have the algorithm. You guys need to use your highlighters or colored pencils. Do the model like we did on the previous page in part 3. And then number 4, you're just going to do the math. So using this algorithm, you're going to multiply 2/3 times 3/5 and tell me what it equals. Questions? Okay, we'll give you guys about 6 minutes. Go ahead and get started. Okay, so let's talk about the model first. So we needed to do 2/3 by 3/5. So which one's the length, which one's the width? Yes? 2/3 or the 3/5? 3/5? Okay. Does it really matter?
No.
Miss Einhorn, is that the way you would have done it? Me neither. I would have gone length width because that's the formula. But it really doesn't matter. So, key bonus question. We didn't do this one earlier. Which property is it that says it doesn't matter if this is the W or that's the W?
And addition?
No. Yes, commutative property of multiplication. Because I'm multiplying, it doesn't matter which way I go, right? So, we called that the width and the length. So to me, width goes this way, length is this way. If you did it the other way, it's okay. So I would break this 2/3. So that's 1/3, 2/3. The other way is now our 3/5. So I'm breaking this one into fifths. So 1/5, 2/5, 3/5, 4/5. If you did it the other way, it's okay. You would have come up the same. So here's where our highlighters come in. So we do two different colors. So the 2/3 is saying, okay, I did 2 of the 3 going this direction, correct? Is everybody okay with that? Again, if your model goes the other way, that's fine, but your 2/3 is going to look kind of the same. I know y'all are really jealous because I'm such a good at coloring, but that's okay. Okay, then we do 3/5. So I'm going to go up 3/5. And we'll color this one in. I can feel the jealousy.
I'm so sick coloring. Awesome. I'm
It doesn't look that bad.
How did you create a color? Oh my goodness, I'm so jealous.
Okay. I did. It's now 3 colors, right? Should make it very easy for us to break this down. So, now that I cut this up, how many blocks did we have in total? So in other words, what's my denominator? Then 15. How many of those blocks have 2 colors? In other words, they now become green because blue and yellow make green. Yes? 6. Okay? Is there anyone who doesn't see those 2 numbers? Guys, be honest. If you don't see them, tell me now. You don't see them? Good. Thank you for being brave. So, my bottom number, 15, comes from 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Do you now see there's 15 blocks? Yeah? And of the 15 blocks, there are these that have both colors, right? How many? 1, 2, 3, 4, 5, 6. See it now? Everybody see that? Okay, so Sawyer, 615, my final answer? Sawyer? Why not? Simplify. What can I do to simplify? By. Go through your 4 key numbers. I can't divide 15 by 2. Three, so I can divide them both by 3. So that gives me 2/5. Make sense?
Yep.
Any questions on where those numbers came from or why the answer was 2/5? So everybody's okay with it? Guys, because here's the deal. We're doing this to cement this in your minds as to why. From now on, it's not going to be cementing it why. We're going to be doing mostly just the math. Okay? So now let's look at the algorithm, because now we're supposed to use our algorithm. So our algorithm says look for reductions, common factor on top and bottom. In other words, I'm going through my 4 key numbers and saying, is there a number on top and one on bottom I can divide it by? Is there a number on top and bottom I can divide by 2? No, because those are both odd. 3? No? There's a 3 here and a 3 here, isn't there? So I can divide both those by 3, right? So what's 3 divided by 3? 1. What's 3 divided by 3? 1. Well, now I've just got a 2 and a 5, so that's my number, so I know I'm done. Step 2, multiply top times top. 2 times 1 is?
2.
Bottom times bottom. 1 times 5 is? Did I get the same answer, one I expected? Yeah? Okay. How many are okay with what I just did on the 3s? How many are like, Mr. Moore, what kind of magic voodoo did you just do? Okay? Here's the magic voodoo I did. Watch what else would happen. If I didn't do reductions, what's 2 times 3? What's 3 times 5? What can I divide 6 and 15 by? So the witchcraft I did was, why do I want to multiply numbers I don't have to and give myself extra options for math errors. Now, who wants their mind really blown? Watch this. 10/27 times 20. Actually, no, I did it backwards. 27/10. Yeah, that'll work. Times 20/3.
No way. How?
Ben?
You're going to divide 27 and 3 by 3 and 10 and 20 either by 5
Or by 10, because I can use bigger numbers if I want to, right? What's 10 divided by 10? What's 20 divided by 10?
2.
What's 3 divided by 3?
1.
What's 9 divided by 3?
27 divided by
I'm sorry, 27 divided by 3. I gave you the answer. 9. What's 9 times 2?
18.
1 times 1? Here's your other option. I can do 20 times 27, which is going to give me 540. Then I can do 10 divided by times 3, which is going to give me 30. And then I can reduce down, and I'm eventually going to get to 18. Do you guys want to do this, or do you want to do this and hope you don't make any big errors? Guys, most of your homework today is going to be mixed numbers, meaning you're going to have really big numbers. And if you don't look for reductions, tonight's homework is going to take you a while. If you do reductions, tonight's homework is going to go pretty quick. Okay? Questions on what we have covered on this page? Because we're setting the stage for everything else we're going to do. Everybody good?
Yes.
Okay. So let's look at this. Going to go to the next page. I wanted to get some more practice with you guys, so we're not going to do the whole area model thing. Instead, I'm going to take a little bit of a shortcut. We do have another algorithm to multiply by mixed numbers. So we're going to just do your algorithm real quick, and then we're just going to show you how to do the math rather than go through all of the models, okay? So here's what we're going to do. Multiplying mixed numbers. Everybody should be on page, what am I on, 37? 36. Page 36, next to this box, you're using the space to write in our notes. Multiplying mixed numbers. We're going to add a step on this to what we did with fractions. The step we need to add is turn all numbers into improper fractions. Now, a quick basketball story to help remember how to do this. For all of you who know basketball, one of the highlight plays is called a slam dunk. In a slam dunk, the basketball player takes the ball, he's going down the court. He gets about the free throw line. He picks it up and he goes really fast, right? Because he has to get it up here. He jumps up in the air and he kind of floats until he gets to the basket, and then he slams it through, right? Everybody familiar with that?
Yeah.
So it goes really fast and then slow. Same thing's going to happen in our fractions. So we've got 3.5 times 2.5. So mathematically, what is our fast operation? What's our fast operation in math? Multiplication. What's our slow one? The inverse one. Addition. So we're going to multiply, then we're going to add. So I go fast, then slow. 2 times 3 is 6 plus 1. That becomes 7/2. Slam dunk. 2 times 2 is
4.
plus 1 is 5. Does everybody understand how we do the slam dunk? Okay? So I'm going to add that to your note. Just as a quick reminder, it's a lot easier to say slam dunk than to say convert all mixed numbers into improper fractions. So if I say slam dunk, that's what we're talking about. Step 2 should look very familiar. Look for reductions. One top and one bottom. You cannot do two numbers on the top or two numbers on the bottom. You need one in the numerator, one in the denominator to do reductions. Your 4 key numbers are huge for helping you, but you can do any number when you're doing reductions. A big one is 10. If I see two numbers that end in 0, one on top, one on bottom, bam, that 0 is gone. Okay? Number 3, same as before. Multiply top times top, bottom times bottom. And step 4, and this one will come in because now you're going to end up with improper fractions, so you need to simplify. So basically it's saying how many times does the denominator go into the numerator, and anything that's left over becomes your new numerator. So continuing in our problem, we have 7/2 times 5/2. Quick side note, if it's a whole number, what do I do to make an improper fraction? If it's a whole number, I just put a 1 underneath it, okay? So if it's a whole number, I'm just putting a 1 underneath it. Otherwise, if it's a mixed number, I'm slam dunking. Mason?
Wait, what do you guys mean by look for reductions one top and one?
We're about to cover that. So I have a 7 and 5 on top, 2 2s on the bottom. Can I do a reduction? Is there a common factor on numbers on the top with numbers on the bottom? Can I divide something on top and bottom by 2? Well, 2 is all I got down there, so I know I'm done. Here's the key, Mason, why I point that out. I can't say, oh, there's a 2 and a 2 and reduce those, because they're both on bottom. Okay? One has to be on top, one has to be on bottom. So I don't have any reductions on this one I can do. So that means I now go to step 3, multiply. 7 times 5 is 2 times 2 is 4. And then we simplify. How many times will 4 go into 35 without going over? 8. That makes 32. So how much is left? 35 minus 32 gives me 3. 35 minus 32 is 3, not 1. Not 33. 8 times 4 is 32. And my number was 35. Questions on what we just did? Okay? So here's what we're doing different than what we've done in the other classes today, partially because they were shorter classes. We've already done all of this, so you guys can skip that page. Let's go to page 38. Okay, on page 38, we haven't really talked about this yet, so let's talk. I'm going to take a second on this one. You can use the standard algorithm to multiply a whole number and a mixed number, or two mixed numbers when solving problems. They're going to make trail mix for an upcoming field trip. She shares a Hawaiian trail mix extravaganza recipe. This is shown for one batch. Guys, recipes is the biggest reason that I hate the fact we haven't switched to metric system. Because we use tablespoons and cups, and we have to do all kinds of nasty conversions. Okay? If we did metric, all of this goes away. But since we don't, we have to understand how to do this. So the figure is going to take 3 batches, because one batch feeds 12 people. So that means they have more than 24 in their class. Okay? Megan said, and you guys see these worked examples, right? You guys see this thumbs up? What does that mean? It means it's approved. It means they did they got the right answer. So we're saying either one of these methods will work. You can do whichever one you feel best with. What is the big difference between how Megan did it and how CJ did it? See if you guys can tell me what the difference is. Nyla?
For Megan, she just divided it just goes by top and top and bottom and bottom.
Okay.
But CJ did that method that you
Do you remember what we just called that? It was on your algorithm on the previous page. Yes.
top and bottom reduction.
Reductions. CJ did reductions. Megan just did the straight up math. Did they get the same answer? Yes. As long as you don't make a math error, guys, you'll get the right same answer. The problem is, she's dealing with 21. He's dealing with it. Came straight out in the answer, right? Which one would you rather do? Come straight to the answer or have to do a lot of extra math? I like CJ's method. Okay? So, does everybody understand how the difference is? CJ did reductions. That was our big difference between them. Because he did the reductions, he's able to get the answer in one step. Okay, we're now on page 39. Here's your chance to show me if you guys have this down. So, determine the number of cups of each ingredient it will take to make 4.5 batches. They've given you 3 different things. You have to go back to the table, which for you guys is on the preceding page. Figure out how much it is for one batch, and you're going to multiply it by 4.5. Once you've done that for all 3 of those, you have 6 problems below to finish. Okay, we've got about 15 minutes left in class. We'll give you guys 8 minutes to finish as many of these as you can. Go. Okay, unfortunately, we don't have a lot of time left. So raisins, it was 4.5, right? So I'm doing 4.5 times 4.5. Slam dunk gives me 9 halves times 9 halves. No reductions. Gives me 81 over 4. So it's going to go 20 times with 1 left over. Sunflower, what was the recipe called for? Quickly. No, that was raisins. It did sunflowers too?
Oh, sunflower, no, 1 and 3, 1 and 3. 1.
Thank you. Glad someone can talk. 1 1/3 times 4.5. Again, slam dunk gives me 4/3 times 9 halves. This one we got some great reductions, right? I can divide by 3. I can divide by 2. Gives me 6 over 1 or 6. If you did the hard math, that was 36 divided by 6. Not terrible, but you can make life easier for yourself. Pumpkin seeds, what did I start with? Then. Two and a fourth. So 2 1/4 times 4.5. Slam dunk gives me 8 9/4 times 9 halves. Okay, here's where the reductions get tricky for those that don't fully understand it. I've got 2 9s on the top. Can't do anything to them because they're both top. I've got a 2 and 4 on the bottom. Can't do anything because they're both on the bottom. It has to be one top, one bottom. Everybody okay with that? Okay, so now I just have to do the math. 81 over 8, that's going to go 10 times with 1 left over. See how easy this can be if you'll do the reductions, guys? Okay, so we've got this part. Do I have time? I apologize, guys. I'm gonna fly just in case you guys got it. So that gives me 5 halves, 17 fifths. I've got 5s, gives me 17 halves, goes to 8 1/2. Okay, this one, I'm gonna get 6 8/3 times 17 fourths. I've got 1 reduction, gives me 34 over 3. So I'll go 11 with the 1/3 left. Okay, 6 7 fourths, 10 12 fifths. I've got 1 reduction, gives me 21 fifths, or 4 1/5. This one, I've got 3 halves times 5 6. I've got 1 reduction, gives me 5 fourths, or 1 1/4. Now this one, 12 15 fourths times 2 over 1. I've got 1 reduction, gives me 15 halves, or 7 1/2. And 16 21 over 8 times 3 over 1. No reductions, gives me 63 over 8. So that's going to go 7 times with 7 left over. So I apologize for going so fast, but that was really just so you can check your answers for those of you that got them all done. If you didn't get them all done, I'd write down the answers and work them out at home to give you some extra practice. But we need to go to the homework. So let's go to page 41. Please pay attention. Explain how to use the standard algorithm. In other words, that first one we gave you. 4 mixed numbers. So it's the second one we gave you. Number 1, this one caused a lot of trouble last year, and I don't get it why. If you mark your text, it's easy. She does it each day. How many miles will she swim? So which line do I need? Swimming, that one. How many days in a week? 7. 7 times 2/3. Okay? The next one, each day in the week. How many will she cycle? I need the cycling line. Do I need the running line? No. Guys, it's irrelevant information. I would hold on for just 1 second so you can get the back page. This one, guys, please, quiet. This one, area. Make sure your units are squared on the area. So you're just multiplying by units squared. Calculate each product, show your work. If all you have is a bunch of answers, are you getting credit? Not a bit. Okay, guys, that's it. Relatively easy homework for tonight. Good luck.